All right, in a previous video, we did talk a little bit about component form of a vector. If you want to just pause and read on this slide, you can do so. For you to have a component form, remember a component is those brackets with a comma, and you have a distance from your x and a distance on your y. Another way to do this, in case you don't want to have to graph it out, is you could take the distance with those two, and you would get your vector in component form. So if you had an ordered pair, if you don't like P1, P2, you could call this X1, Y1, and X2, Y2. It's the same thing as P1, P2, Q1, Q2. And you would take the distance between those X values and Y values. The next thing is magnitude. We talked about that. So a vector, to have magnitude, is noted with the vector with the double brackets represent the length. And again, we use the distance formula. So we've already done that a little bit. So those are the two things that you must know within a vector. All right. And the last thing we talked about on this slide, again, we did an example with it. For two vectors to be equal, they must have that same direction and same length. So that just kind of walks through that one. So let's go back and do a couple of problems quickly in our graphically, and then we'll do it more algebraically. So if we want to find the component, for example, A, we would graphically count the distance across on the x-axis. So 1, 2, 3, 4, 5, 6, 7, 8. So there's a distance in a positive direction, 8. And then if I change colors here and we go down 2 in a negative direction, what that vector will look like is a positive 8. That's your x-axis. And then a negative 2, because that's your y-axis, your y change. All right, let's do one more example over here. So we have our vector in the red, and we want to cut across and count 1, 2, 3, 4. So that's going to be your x of your component. And then we go up 1, 2, 3 in a positive direction on your y. So the component's going to look like this, 4, 3. And then if you want to find the distance, the magnitude, you would use your distance formula. Now we'll do that on the next examples, is find those magnitudes. All right, here's just the solution for those that we just did. All right, so here's our example. We have an initial point of 4, -7. So that's graphed down here. And then we have a terminal point of -1, 5. So there's your Q. So you're going off and graphing this vector PQ, and you're calling it vector V. So we could sketch the graph, and then we can find the two pieces, the magnitude and the component form. So graphically, this is our graphic solution. We've done this already. Here is your change in x. So you're moving 5 to the left, and then this is your y change, and you're counting up 12 units. So your component form would look like this, -5, 12. Then you can find the distance using your distance formula, and the magnitude is 13. So that's how you can describe that vector. Now below this green line is just the algebraic solution, finding the distance from the x change and the y change. So this is subtracting them and subtracting them to get -5, 12. And this is showing that distance formula to get you 13. So again, above this green line shows you it graphically, below is algebraically.